In the second case, when the velocity is not small or the mass of the object is not small, the resistive force can be proportional to the square of the velocity. And when we write down the magnitude of the resistive force, we will have that R is equal to the half of d rho a v square. Okay. This d is a constant, and we call it the drag coefficient. The drag coefficient. Rho is the density of the object. Oh, sorry. Sorry. Rho is the density of the air. Rho is the density of the air. And A is the cross-sectional area of the object. Rho is the cross-sectional area of the object. This drag coefficient, the value of the value of drag coefficient is depend on the type of the object and the medium that the object moves through. Okay, and if it's the air, so we have the drag coefficient of the air. This is the density. To be precise, we should say that this is the density of the medium. Okay, so if it's the air, so this is the density of the air. Okay. Again, we can write down the net force F is equal to the summation of the weight and the resistive force. So we have that net force is equal to the mg minus half of the d rho a v square. Please note the minus sign here, because now we take the positive downward direction. So mg is positive and the resistive force point upward against the motion of the object. So we have this negative sign. We also neglect the buoyant force here, by assuming that that force is very small. The acceleration of the object is equal to the net force over m. So it's equal to the g minus half of d rho a v square over m. Okay. And again, we can define the terminal velocity. That is the velocity when a is equal to 0. So the terminal velocity or terminal speed, we can calculate the value of the terminal speed by setting a equal to 0. It's equal to the g minus d rho a vt square over 2m. So we get the terminal velocity Vt is equal to the square root of 2mg over d rho a. This is the value of the terminal velocity in the case that the resistive force proportional to the square of the velocity. Again, we can use this expression to experimentally determine the value of the drag coefficient, because if you leave the object to move in the medium for a while, the velocity of the object will become a constant, because the resistive force cancel the gravity. So we know, if we know the mass of the object, we know the cross-sectional area of the object, we know the density of the medium, and we measure the terminal velocity. So we can calculate the drag coefficient from those data.